Hello everyone, welcome to another SQL tuning case study. My name is Vijesh and today we are going to see a new case study based on poor joining condition. But before that, don't forget to hit the subscribe button to stay tuned on all the latest updates. So let's start our case study based on poor join condition. So this is the SQL query. Select e dot first name, e dot last name, e dot hire date from employees E, departments T, and locations L. So there are three tables which are joined together. Where clause e dot employee ID is equal to 200, d dot department ID is equal to 50, and then we have a join condition on department ID for employees and departments table, and a join condition on location columns for departments and locations table. So looking at this query, the output we are going to get is only one row, and this is the execution plan which the Oracle has generated when we executed this query. So if you see here, there are 45 rows which are being scanned at the sixth operation, that is index range scan here. However, the output of the query is only a single row. Okay, so let's see whether this 45 extra scanning of the rows can be avoided or not. Okay, so before that, let's go back to our fundamental approach for query tuning, which says that we have to start with such a column in the where part of the clause which has got too many distinct values, right? So in this case, we have only two columns. One is e dot employee ID and the second one is t dot department ID. So when strange thing here is both the columns are primary key in their respective tables. For example, employee ID is a primary key in the employees table, and employee ID is equal to 200 is going to give you only one row, right? And this one row can be used further for the join operation. Similarly, department's ID column in departments table is again a primary key. So department ID is equal to 50 is again going to qualify for a single row. And this single row will further go in for the join operation. So now let's see whether starting with employee ID is equal to 200 is going to be beneficial, or starting with department ID is equal to 50 is going to be a beneficial. And I will see how this join condition turns out to be a poor join condition. So if I start with e dot employee ID is equal to 200, okay, so this clause is going to give me only one row, right? This one row will be further given for the join operation with the departments table, right? Okay, and the resulting join operation will again be a single row. Why? Because in departments table D, department ID is a primary key, right? So that's why this join operation is going to give me one row. Further that, then the departments table is going to join with the locations table using the location ID column, right? And then this join operation with the locations table is again going to give me single row, because location ID in locations table is a primary key. So this means that if I start with e dot employee ID is equal to 200, I'm going to scan only one row for each operation, and the output I will be getting is only single row. Okay, so what made this execution plan to scan 45 rows? That is what we are going to see today. So in this case, what Oracle actually did is, instead of starting with e dot employee ID is equal to 200, it has started with d dot department ID is equal to 50. So in departments table again, department ID is a primary key. Okay, so d dot department ID is equal to 50 is going to give you only one row. Okay, so this one row is further given for the join operation with e dot department ID is equal to d dot department ID. Now the problem here is department ID column in the employees table is having very less number of distinct values, which means that department ID is equal to 50 in the employees table is going to qualify for too many rows, which in this case is exactly 45 rows. Okay, so that is the reason why we are getting this extra 45 rows here. So this join operation is going to give you 45 rows, right? Now this 45 rows is further given down to this join condition with the location ID column on the locations table. Now since location ID is a primary key in the locations table, this join operation will going to give you 45 rows as it is. So this path turns out to be a lengthy path. Why? Because the output is only one row. However, we are unnecessarily scanning 45 rows from the employees table for the department ID is equal to 50. So this means that for any join operation, the table which is not yet taken part in the join operation the column associated with such a table should have too many distinct values or should be a primary key, so that the resulting join operation should give you same number of rows as the number of rows which it has given from the access operation, that is employed is equal to 200. So this means that for any join operation, the column which has not yet taken part in the join condition should have too many distinct values or should be a primary key, rather than being such a column which has got less number of distinct values, right? So in this case, in the employees table, department ID is not a good column. So that is the reason why this query is taking 45 unnecessary rows, right? So what we can do to make this plan work or make this query executed in a better way is we have to start with e.employee ID is equal to 200. So before that, let's see the execution plan and verify whether what plan Oracle has taken. Okay, so if you make a parent-child relationship, fourth operation will execute first and then third operation will execute. So what is the fourth operation? So fourth operation is accessing the departments table based on department ID is equal to 50. So this means that Oracle has executed this operation, right? D dot department ID is equal to 50 and it has given scanned only one row. Now what is the next operation? Third will execute later. Okay, table access by index row ID, and then sixth will execute. And what is the sixth operation? It is accessing the employees table for the department ID is equal to 50. That means E dot department ID is equal to D dot department ID. This operation is going to get executed. So here you see there are 45 rows which are being scanned from the employees table. That is because in the employees table, department ID is equal to 50 is going to qualify for 45 different employees, right? So that is the reason why it is taking a lot of time. So the conclusion was it is expecting only one row from the select query. However, it has scanned unnecessarily 45 rows. Okay, so what we can do to avoid this, the solution is you have to start with e.employed is equal to 200, so that this will give you only one row. This one row will further be given for the join condition on d.department id. Now since in the departments table department id is a primary key, this join operation is going to give you only one row, okay, rather than 45 rows. So how to make this work? So we'll pass a hint leading E, which will tell Oracle to start with the employees table first on employee ID column. Okay. So if you want to see the index statistics and the table statistics for the employees and the departments table. So for this is for the employees table. So it is having 107 distinct values, while for the department ID column, there is only 11 distinct values. So that is why in employees table, department ID is not a good column or is a poor column. So let's go back to the resolution. So in order to resolve this query, we have just put this hint leading E. So this will tell Oracle to start with e.employed is equal to 200. Okay. And then this will go with the join operation for d.department ID, which is going to give you only one row because the department ID is a primary key in the departments table. And then this will further go for the join operation on the locations table, right? So location ID is the primary key in location table. So this join operation is again going to give you only one row, right? So let's verify the execution plan. So this is the execution plan after we put the leading E hint. So if you again go back to the parent and child relationship, fourth operation will execute first. So fourth operation is built on e.employed is equal to 200 and it has given you only one row, right? So this row is scanned and you're getting one row. Next, third operation is executing. Third operation is table access by index row ID. So it is filtering out department ID is equal to 50. Will be filtered out because we have one extra condition here. And since this column is part of join condition, Oracle before joining will try to validate whether for the employee ID 200, the department ID is 50 or not. Later, sixth operation will execute. So sixth operation is d.department ID is equal to 50. So that means this operation is going to get executed. And it is expecting only one row as part of the join operation because department ID is a primary key in the departments table. So that's the reason why putting leading E as the hint in this query, all the rows for each operation you are expecting only one row, and the actual output of the select statement is also one row. So that was the case study for today. Hope you liked it, and keep watching for further videos. Thank you.